All right, so this is start of chapter 5, right, on solving systems of linear equations. Now, I want you to look at the picture. Don't open it yet, just look at the picture. Okay, don't open it yet. Look at the picture. Louis, what do you see on the front cover? It's all chapter 5 is about, intersecting lines. Okay, lines can do one of three things. They can intersect, or they can trace. There you go. Intersect, or what's the opposite of things intersect? Parallel, very good. Or not intersect. So lines can do intersecting, not intersect, or they can be the same line, Chucky. Okay. So what we're going to have to do is we are going to have to figure out these solutions somehow. Okay. Now the way to figure it out, whether they intersect or not, the first way we're going to talk about is graphing. Got that, Tyler? Gonna fix that mask. There you go. All right, is graphing. So the only thing we need to do is take two lines and plot them on the same coordinate plane. Does that make sense to you? All right. So first, let's get into, where's your water bottle? Okay, cool. All right. First thing we're going to get into is just a little bit of vocab and things like that. So, Joey, a system of linear equations is two or more equations. Does that make sense to you, Joey? Two or more equations. Hey, let's get out our notes.
I didn't know it was that book.
Hey, you promised me you would have it.
I just didn't know it was this book. I have the other book.
All right.
I swear I'll have it tomorrow.
All right, so two or more equations. Now, a solution to a system of equations is the point that, and I'm going to use this term lightly, balances the equations. And what I mean by balances is when I plug it in, it works for both equations. It makes the left side equal to the right side. Okay? If it doesn't, then it's not a solution. Okay? Ava, up here we have two equations. Do you see them? The top one and the bottom one. Do you see that? Okay. And I'm being asked to determine if 0, -4 is a solution, meaning does it balance it out? So Ava, what's the first step I need to do? Label. So everybody label your point X, Y. Annie, what's step number 2? Now I have two equations that I need to write. I have X plus Y equals -4. And I have X minus 5Y equals 20. Do you guys see that? It's all about those steps. Got that, Chucky? Make sense? So I label, write my equations, not equation now, and now it's equations because we're talking about systems. Tyler, what's step number 3? Substitute. Now I'm going to kind of do this one at a time. So I'm going to do the one on the left first. So I'm going to plug in 0 for X. It says 0 plus -4. And I'm asking, is that true? Is that equal? All right. So what is 0 plus -4, John? -4. Is -4, John, equal to -4? So I put a check mark to signify that that it is balanced, okay? Now, just because the one on the left worked, doesn't mean it's a solution. I have to go ahead and plug it in to the one on the right. So Tyler, what's step number 3? Substitute. So now I'm going to go to the other equation and substitute in on that side too. So you plug in 0 for x. It says -5 minus 4 equals 20. Well, what's -5 times -4, Louis? 20. And I'm asking, does 20 equal 20? Is that true or false? Now that I've determined that it worked in both, I will write 0, -4 is a solution. Got it? All right, can I erase that? Chucky, can I erase it? All right. Annie, what's step number 1? Nate, if you don't have your notes or anything, then you need to follow along. All right, we can't be texting the whole time. So Annie, I need a label. Very good. Ava, what's step number 2? Write your equation. Now I have 2 of them. I have x plus 2y equals 9. And I have 4x minus y equals 15. All right. Chucky, what's the next step? Substitute. So I'm going to substitute it in on this one on the left, okay? It says 3 plus 2 times 3. Is that equal to 9? Well, what's 2 times 3, Chucky? Is 3 plus 6 equal to 9? So I put a check mark. All right, now let's go to the next one. The next step is to do what, Chucky? Step number 3. So I'm going to do 4 times 3 minus 3. And I'm asking, does that equal 15? Nate, what's 4 times 3? Yeah. Is 12 minus 3 equal to 15? No. So I like to cross it out. And when it doesn't work, I will write 3 is not a solution. You guys okay with that? All right. You guys try C. Keep going, Chucky. You can do it. Joey, come on. Joey. Right, what I have on the board. Yeah. Try and split it apart. All right. You want to take them? Oh. Did you write what I have? Yeah. Okay. Did you label your point? Did you plug it in? Did you substitute?
Why not?
Did you substitute? Did you simplify? Worst that happens is you get it wrong. It's okay. All right. So try to do it on your own. Okay. You don't get it right, it's okay. Because you'll learn more from a mistake. All right. Now, Mike, what I'm going to do here is I'm going to substitute in 1 for x. So I have 2 times 1 minus 3 times -2. And I'm asking, does that equal 8? Well, 2 times 1 is 2. -3 times -2 is 6. So I have 2 plus 6 equals 8. Mike, is that true?
Yeah.
Very good. So it is true. Now I'm going to go to the other equation, the 3x plus 2y equals -1. Now I'm going to do 3 times 1 plus 2 times -2. And I'm asking, does that equal -1? Annie, what's 3 times 1? And what's 2 times 2? Is 3 minus 4 equal to -1, Annie? Yeah. Because it is, I'm going to write 1, -2 is a solution. Tyler, did you get that one side right? It looked like you were along the right way. Louis, you following along? Okay, I'll give you a chance. Maybe you doing okay with this? Not too bad, right? So did you get this all down? Yeah. You did? Tyler, did you get it all down? Okay. All right. So, as you can see, the solution is the point where they meet. It's the point that balances it out. It works for both equations. Now, like I said, there's a couple different ways to, I guess, find that answer, Tyler. The first way we're going to talk about is graphing, okay? So what we're going to do is we're going to graph the two equations on the same coordinate plane. Once we do that, the lines will cross, they won't cross, or they'll be the same line. And I can figure out my answer from there. All right. Now, graphing for me, okay, it's very pretty. It looks great. If I'm doing a presentation, I'm going to show graphing, okay? Because it's easy for you to see, it's easy to follow along. But it's actually the most useless method, okay? And the reason for that is, well, sometimes the intersection will not be in the corner of a box. And when that happens, we have to estimate. And I don't like to estimate. All right. So this method is where I like to start out. But then as we move along throughout algebra, I kind of move away from this. You guys okay with that? All right. So let's go to the next page. Now I have a bunch of graphs. Okay. And this is the time, if you have a second color, that would be good. If you don't, one's fine. All right. Also, if you have a ruler or a straight edge, please get that out. Okay. Now, things you could use for a straight edge. Most of you already have your phone out. You can use the side of your phone. You can do what Mrs. Simonia does. You use your ID card. That works. All right. But a ruler will be helpful, Chucky, because the more accurate you are, the better it's going to be. Okay. And your grade for this is based upon accuracy. So you want to be accurate. Got that? Okay. So it's up to you. Now, I'm going to use blue for my first one. If you have two colors, just put a circle, like a little dot next to the top equation. This is going to be our first equation. Tyler, with this, it says, guys, it says what? It says to start at 6. Remember this? We started 6 when we were graphing. So everybody go up to 6 on the y-axis. Put a point. Now, that tells us what? That's our slope. Grace, do you remember what that negative means? Up or down? Down. So it's going to be down, right? And now we have to figure out how many. If there wasn't a number there, what number could we put there? Do you remember that? 1. And we wanted it to be a fraction, so we made it 1 over 1. This has to go down 1 and to the right 1. So everybody, we're going to put a bunch of these points on here. We're going to start here at my starting point, then we go down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. And keep doing that. Does everybody have a bunch of points? Now I want you to take your straight edge, like your phone, your ID card, or whatever, and put it on those points. Okay? And I want you to draw a line. Does everybody get a line that looks like mine? Right? All right, take your next color. Mine will be green. Same thing. Except we start at -2. And this says instead of going down, it says to go up. So we're going to go up 1 to the right 1. Up 1 to the right 1. And I like to keep doing this all the way throughout. So if I need to, I can draw my line. Now, Ava, this is pretty easy to see where they cross, correct? Right? 1, you have 2 colors. 2, the lines cross pretty easily, right? So my solution is right there. What is that point? It is 4, 2. That's my solution. Chucky, do you see how I did that? All right. Let's look at number 2. Number 2. This is start at 1. Then it says to go down 2 to the right 1. Down 2 to the right 1. Down to the right one. Jules, how you doing at home? Jules, you doing all right?
Yeah.
Uh-oh. Oh no. Yeah, I just drug it down too far. All right, so there's my red line. Annie, got it? Now, this one says to start at -5. And it says to go up one to the right one, up one to the right one. Okay. Where did my two lines meet, Nate? Well, they meet right there, right? What is that point? That's my solution. It's the point 2, 1, 2, 3, 2, and -3. Are you good with that, Nate? Ava, you okay with that? Louis, you okay with this? All right, so let's look at number 3. Number 3, y equals x. So Tyler, there is no number for the starting point, right? The starting point's the number out here. Notice there isn't one, correct? It means start at 0. Now, Tyler, what am I counting by on this one? No? 4s? No? 3s. So I got to pay attention to my intervals. So I'm going to go, think about it. The slope's 1, 1, right? So I'm going to go up 1 to the right one. I'm going to ask me up 1 to the right one, up 1 to the right one. So I'm really going, notice slope is kind of funny. It's a fraction, right? My slope is 1/1. But Joey, what is 3/3? 1. So if I go up 3 to the right 3, I'm still going up 1 to the right one. So I have my points here. Connect my dots. All right, ready, John? This one says start where? It says to go up how much? Ooh, that one's gonna be tough, right? Up 4, so that's 3, 4 into the right one. I have to estimate. Up 4, I'm at -5, so up 4 is at -1. It's the right one. It's right there. Up 4, 1, 2, 3, 4. It's the right one. Up 4 from 3, I'm at 7. Okay, it's the right one. So it looks like where do they cross, John? 3. What was the other point? 3, 3. So my solution is 3, 3. You guys okay? So far, so good? All right, why don't you guys try number 4? Seeing me today on the run. Yeah. Get it all done. Did you get the one done? Okay. So try and fix it. It's okay. Nobody's judging. Dramatic. Just like they would be if they throw in the trash in a couple weeks or burn. All right, Joey. For number 4, we started 2, right? Everybody put a point at 2.
Oh.
And then Ava, it says go down 2, right? And to the right 1. Down 2 to the right 1. Down 2 to the right 1. You okay with that? So I don't have a lot of points here. But you guys will be fine because you have a ruler, right? Or a straight edge. I don't. So I'm going to use like my straight edge, which is known as this line function. So I put my point there and I connect my dots. Are you okay with that? It's my line. This guy. Where do I start, Ava? Where do I get my other point? Go up 1 to the right 1. Now I really don't have a lot of points, correct? But that's okay. So notice if I have a straight edge, I can put this down and I can Now, mine didn't really cross in the corner of the box, did it? So Annie, what we have to do when this happens, because it inevitably will happen, you have to estimate. Where do they look like they cross? Annie, where do mine look like they cross? What was that? Other way around. -1 and 4. So they look like they're going to cross right there. So -1 and 4 is Andy's guess. Now, whenever it doesn't exactly cross at the corner of a box like mine did, yours might have, but who knows? What you got to do is you got to do what we were doing earlier, label your point, and then we're going to plug it in. So y is 4. So I'm asking, does 4 equal -2 times -1 plus 2? Louis, is that true or false? Does -2 times -1 plus 2 equal 4?
No.
It does. So it works for the top one. How did I? All right, let's check it for the bottom one. Eva, does 4 equal -1 plus 5? So my solution, even though my graphing was off, my solution that we found was still correct. Okay? Do you guys get that? Do you see why it's very important to be accurate? Because I was trying to be accurate and I was still off a little bit. Okay. Now, you guys are going to have a little bit of homework.